Good morning. Today I'm going to explain some things from chapter 11.3. We are dividing polynomials. You can have a look in your textbook. There is some extra examples starting on page 666 in your textbook. These first two examples, there is another example for you. Now, these ones here, these ones you can kind of think about like we did yesterday, right? If we've got this divided by this, it's the same thing as multiplying by 1 over 5b cubed. I mean, the other way to think about it is just to distribute this 5b cubed, but instead of multiplying it, we're dividing it. So in other words, and this is a little bit, I guess I'm just skipping the first step that the textbook does. It's like saying 5b to the power of 4 divided by 5b cubed. Then we've got minus 15b squared divided by 5b cubed plus 1 divided by 5b cubed. So you can see all I'm doing is I'm taking this and I'm dividing it into each of the three terms. Now we simplify. This one, the 5's cancel out, 3b's cancel out. We got b left here. 15 over 5 gives me 3. These two cancel with 2 of these. We'd be left with 1b on the bottom. This one here, we just have 1 over 5b cubed. So that would be your answer. Okay, the second example here, same thing. So you would have 12c to the power of 4 divided by 6c. You would have 18c squared divided by 6c. You would have 9c divided by 6c. 12 divided by 6 is 2. 4 minus 1 is 3. So we have 2c to the power of 3. Or in other words, this 1c cancels out with one of these. 18 divided by 6 is 3. One of these cancels with one of these. We're left with 1c on top. Here the c's just cancel out. We're left with 9 over 6, which you could also write as 3 over 2. So there's your answer for that one. All right, now we're going to have a look at some different ones. Now we're going to divide by a polynomial. Now with this one here, we're basically going to be doing long division with polynomials. Okay, so the way to start it is you take this one here. We're going to say we're dividing m plus 1 into this. Okay, now this first example here, notice that we have it in standard form, like our biggest power all the way down to our lowest power on both of these. Okay, this is called the divisor. This is called the dividend, and the quotient is going to be our answer. Now, what we have to do when we do this is you want to figure out m times by what would give me 2m squared. I would obviously need a 2, and I would obviously need another m, right? In other words, 2m times by m would give me 2m squared. Okay, 2m times m would give me 2m squared. 2m times by 1 is 2m. Okay, so once I figure out m times by what gives me this term, I write it up here. And then I take this term and multiply it to both of the things in the divisor. Okay, now I'm going to subtract this. So 2m squared subtract 2m squared is 0. That's what we want. Negative m subtract 2 would be negative 3m. I need my other term here. I'm going to drop that down, negative 3. But I'm just asking myself, I'm looking at this first term here. M times by what would give me negative 3m? Well, I'm thinking negative 3. Negative 3 times m would be negative 3m. Negative 3 times 1 is negative 3. So when I subtract those two things, it all cancels out and I get 0. So that means I have no remainder, which means this is my answer, 2m minus 3. You can always check your answer. If there's no remainder, it's easy to check. You can check to make sure that 2m minus 3 times by m plus 1, right? If those two things multiplied together equals this, then we're right. All you got to do is use FOIL to distribute those out. 2m squared plus 2m minus 3m minus 3 you can see that those two were combined in negative m. So therefore, we have the correct answer. Let's have a look at this one. This one's a little bit different. We're going to start the same way. We've got q minus 1. We're going to divide that into this. Notice how if our biggest term is to the power of 4, we have no term to the power of 3. You actually have to say 0 q to the power of 3. Otherwise, this long division is not going to work. Okay, so that's something very important to remember. So we're asking ourselves, q times by what would give me q to the power of 4? Well, I'm going to need q to the power of 3, right? Because 3 plus 1 is 4. Q to the power of 3 times by q is q to the power of 4. Q to the power of 3 times by negative 1 is negative q to the power of 3. Remember, when you subtract a negative, it's like adding. So 0 plus 1 is going to be positive 1 q to the power of 3. So now I ask myself, q times by what gives me q cubed? Well, I need q squared. Q squared times q gives me q cubed. Q squared times negative 1 gives me negative q squared. I'm going to drop this one down. Then I'm going to subtract them. Remember, subtracting a negative is adding. So we got 1 plus 1 gives me 2 q squared. Q times by 2q would give me 2q squared. 2q times q, 2q squared. 2q times negative 1 would be negative 2q. I have to drop this one down. I'm going to subtract them. These ones cancel. 1 plus 2 gives me 3q. So now I'm figuring out q times by 3 would give me this. So I need that to be a positive 3. 3 times q would give me 3q. 3 times negative 1 would give me negative 3. If I drop this down here, I've got negative 3. You can see if I were to subtract those two things, I would get 0. So we have no remainder. In other words, this is my answer. You could again check that by multiplying this by this to see that it works. My last example here, a little bit different. Now we've got these things out of order. Remember, they want to be in standard form. So instead of writing 5 plus 6a, you want to write the a first. You would want to write 6a plus 5. You want to divide that into this. You write your biggest power first. That's standard form. 18a squared, 21a, 2. We look at our first term. 6 times what would give me 18? 3. A times what would give me a squared? I need an extra a. Right? So 3a times 6a would give me 18a squared. 3a times 5 would give me 15a. When I subtract those, these ones cancel. 21 minus 15 is 6a. So 6a times what gives me 6a? Has to be 1. Right? 1 times 6a is 6a. 1 times 5 is 5. I drop this one down. You can see when I subtract here, 2 minus 5, I'm going to get negative 3. Now I have a remainder. This remainder is going to be part of my answer. I have to say minus 3 out of this, 6a plus 5. So that's how you write a remainder. So you can see this one doesn't divide perfectly, but it gives a remainder of negative 3. So you can write 3a plus 1, remainder of negative 3, or 3a plus 1 minus 3 over 6a plus 5. Okay, so you're going to have to think about these things, go through step by step. Okay, think about what I've been doing. What I want you to do is read the concept summary on the bottom of page 668. You can also look at problems 2, 3, and 4 in your textbook. Make sure the steps make sense in the examples that I've shown you. Okay, there are 5 steps written in the concept summary, and then those steps just repeat. Okay, take your time. See if you can figure some of these out. Hope you have a great day, and I will see you Wednesday.